Hello everyone, my name is Peter Chan P. Umawan,
I am Lawrence John P. Manlangit.
And I am Ras Kevin E. Hal.
and today we are excited to present our initial project proposal titled Wound Ointment from Tamarind Tree Bark.
This study explores the medicinal potential of tamarind bark in wound healing.
And also how it can be developed into a natural alternative and conventional treatment.
Nature encompasses the vast array of living organisms and their environments on Earth, forming a complex web of life that sustains and enriches our planet. At the heart of this intricate system are plants, multicellular organisms that play a pivotal role in maintaining ecological balance. Through the process of photosynthesis, plants convert sunlight into chemical energy, producing oxygen and forming the foundation of most food webs. They provide essential resources such as food, medicine, and oxygen, making life possible for countless species, including humans. Studying plants, a field known as botany, allows us to understand their critical contributions to ecosystems and their importance in our daily lives. The tamarind tree or Tamarindus indica is a tropical and subtropical tree known for its distinctive sweet sour fruit. Belonging to the Fabaceae or legume family, it is native to Africa but widely cultivated in Asia, India, and tropical regions worldwide. The tree is large, evergreen, and slow-growing, with a spreading canopy and feathery compound leaves. It produces brown, pod-like fruits containing a tangy, edible pulp used in culinary, medicinal, and industrial applications. Highly valued for its shade, timber, and nutritional benefits, the tamarind tree plays an important role in traditional medicine and cuisine across various cultures.
So we'll first start with the background of the problem. So wound healing is a complex biological process that can be hindered by infections and delayed tissue regeneration. And commercial treatments such as antibiotics and synthetic ointments have limitations, including the risk of antibiotic resistance and allergic reactions. This has led researchers to explore natural alternatives such as like tamarind tree bark, which has long been used in traditional medicine for wound care. We will now start with the second slide, which is the literature review. So, scientific studies have revealed that tamarind bark contains bioactive compounds such as flavonoids, tannins, and saponins, which exhibits antimicrobial, anti-inflammatory, antioxidant, and wound healing properties. So we'll start with the first, the antimicrobial properties. So studies show that tamarind bark extracts inhibit bacteria like Staphylococcus aureus and E. coli, which reducing the risk of infection. Next is the anti-inflammatory effect. So research suggests that tamarind bark reduces inflammatory by decreasing pro-inflammatory cytokines. The next is the tissue regeneration. So, study shows that animal models have shown that tamarind bark extract accelerates wound healing by promoting collagen synthesis. And these findings suggest that tamarind bark could be a promising component for developing an effective wound ointment.
So next is we have the statement of the problem. So our study seeks to answer 4 key questions. First is effectiveness. How will the tamarind bark promote wound healing and prevent infections? Second is safety. Are there any potential side effects or allergic reactions. Third is mechanism of actions, which bioactive compounds contribute to its therapeutic effects. And fourth is for formulation and standardization. Can tamarind bark be developed into a safe and consistent ointment for clinical use? So by addressing these questions, we aim to validate the potential of tamarind bark as an alternative to synthetic wound care treatments. To test the effectiveness of tamarind bark, we will conduct an experimental study using albino rats as our test subjects. Our research framework includes theoretical basis, wound healing theory, and herbal pharmacology theory. Independent variable is tamarind bark extract ointment, and dependent variable is wound healing rate. Our control group are rats treated with petroleum jelly as placebo. We will observe the wound contraction, infection control, and tissue regeneration over a fixed period to compare the effects of the tamarind-based ointment with the control group.
To extract the medicinal compounds, we will use an upside-down steaming method where the bark is heated under the soil to obtain the extract. The extract will be mixed with petroleum jelly in a specific ratio to create a stable ointment. After formulation, the ointment will be applied daily to the wounds of test subjects, and their healing progress will be documented through measurements, photographs, and behavioral observations. Our data collection process includes, for our baseline measurements, initial wound size and characteristics; for our daily observations, monitoring redness, swelling, and infection signs; for our photographic evidence, documenting wound progression over 14 days; for our statistical analysis, comparing the experimental and control groups to determine the ointment's effectiveness. We will use descriptive statistics and narrative analysis to interpret our findings. We anticipate that tamarind bark extract will demonstrate strong antimicrobial and healing properties, making it a viable alternative for wound care. This research is particularly important for, first, sustainable medicine, using plant-based treatments to reduce dependency on synthetic drugs. Second, healthcare accessibility, providing a cost-effective wound treatment, especially in rural areas. Third one is scientific innovation, contributing to the development of plant-based pharmacology.
In conclusion, our research aims to bridge the gap between traditional medicine and modern science by investigating the wound healing potential of tamarind bark.
And with further validation, this study could pave the way for a natural, effective, and affordable wound treatment option.
Thank you for your time and interest in our research. We look forward to your feedback and insights.